Good morning, sir.
Good morning, Amrita. Good morning, battalions. This
Good
who joined
afternoon,
with
sir.
IK? Yeah, good morning. IK. Who joined with IK name? May you know your name, please? Somebody joined with the IK.
Hello.
Yeah, what's your name,
Good
sir?
morning. Ikram.
Okay, hi, Ikram. Welcome to the class.
Thank you, sir.
All right. All right, guys. So let's start the session. Isaac, let me share my screen and we can start the session. All right. So yesterday we did discussion about the network design. We understand how we can design the network. Basically, we understand about the home network design, enterprise network design, and also we understand about the ISP network design. And we also understand how these network are going to serve different purpose and what kind of devices basically we are going to connect at a very high level. And then we understand the two-tier architecture, how if you want to build the switching in the two-tier architecture, how it can be designed. If you want to build the switching means LAN campus, means campus LAN, or might be the any kind of the collapse code design, or you want to make the three-tier architecture where you all core layer, distribution and access layer is going to be there. Then how those are going to be designed. What are going to be step-by-step approach to design those kind of network as well, and which devices are going to connect on which layer, and what is the use case for different layer where devices are going to be connected. So I hope everyone understand that. If you have any question, feel free to ask me so I can just take those questions as well. Else I will discuss one step ahead. That is the high availability. Also, we discuss about the high availability about the link level. Means any kind of the link is going to down. Let's suppose if this link is going down, what is the impact is going to happen? If this link is going down, then what is the impact is going to be happen? If entire switch is going to be down, then what impact is going to be happen? If both switches are going to be down, then what impact is going to be happen? If this device connected on the access layer, if this is going to be down, then what is the impact? Similarly, on the core layer, if any link is going down, then what is going to be impact? Those we already understand and discuss about that. So I am assuming anyone not have any questions and everyone clear about it. So if you have any question, please raise your hand or ask me so I can take that questions. Now we have to understand about the high availability techniques such as the redundancy, FHRP, and SSO. So what is the FHRP and what is the SSO and what is the high level technique we should use in any kind of the network design? Means you want to architect any kind of network, you are the network architect, or might be the security architect, or might be the network engineer. Then you, if you have to design the network which is going to be highly available means in case of any failure is going to happen, you have the quick recovery. Either my device is going to fail, then also we have the quick recovery. And if my any kind of the link is going to be down, then also we have the quick recovery. So let's understand. So if you talk about the FHRP, first of all, this FHRP is known as the first hop redundancy protocol. This is known as the first hop redundancy protocol. In this first hop redundancy protocol, we have a three protocol. The first is going to be HSRP, the VRRP, and third is the GLPP. So we'll discuss in detail what is the HSRP, VRRP, and GLPP. Let me give the for time being as a high level. Why this FHRP is going to be useful for any kind of network design? If there is no FHRP, then what is the problem is going to happen? So FHRP is about the first hop. What is the very first hop? Anyone know what is the first hop? if someone is talking about the first hop, what does it mean first hop? Any idea anyone have? If somebody is talking about the very first hop, if I'm going to say, can you just tell me your first hop of your device? So what is your first hop? Any idea?
Adjacent router
And just talk about your PC. Let's suppose you have your PC and
next to next to the, for example, I have one and two, then like respective to one, second would be my first, like second PC would be my first hop.
It's a
second,
gateway of network.
yes, gateway of the network is the right word. Yeah, that's just correct. Also, Dinesh, you also very close. But we are talking about the any PC, any PC, any laptop, any server, any even router. If you're using the any kind of the gateway, like default route or any specific route for any specific destination, that is going to be gateway. Means next hop. That's also correct. But for point of view, what we're discussing right now, FHRP is specially designed for the gateway level redundancy. Gateway redundancy means any PC, let's suppose this is my R1, this is my R2. Okay, there is one switch connected here. And switch connected over the PC. Now these two ISP means these two router ISP router connected with the ISP. This is my one link, link 1, and this is my link 2. So if I want to send the traffic to the google.com, let's suppose 8.8.8.8. And this PC, let's suppose I'm using the LAN, subnet is might be 10.10.10.2, 10.10.10.3, and this PC IP is going to be 10.10.10.4. What is a gateway? Anyone know? In that case, what gateway I am going to take? R1 or R2?
You want to configure it, you want to configure some type of redundancy here, just in case one of the routers goes down.
Mm-hmm.
So it can either be that 2 or that 3.
Yeah. Okay, so if you're right, Vodalian, so I need to configure any kind of the redundancy or HA. So in case of any router is going down, so that is going to help. But let's suppose I'm not going to configure any kind of the redundancy right now. Let's understand the problem. Let's understand if this PC want to go on the internet. So what is the best way? Can I configure this IP as a gateway or this IP or both? What I can do that? Both or can configure only one?
Only one, sir.
Sorry, so only one I can configure.
Yes.
Can configure either R1 interface or R2 interface. So if I'm going to configure, let's suppose R1 as a gateway. So what problem is going to be happen? The problem is going to happen if this router is going to be down. Does this PC have the internet connection or not?
No.
No, definitely no. If this link going down, does this PC have internet connection? No.
No.
If this link is going to down, does this PC have internet connection?
No.
No. In case of any failure which is happening in this particular network side or the router side, any link, any device, any WAN circuit, we do not have any kind of redundancy. So that means this network is not a redundant network. Means if I want to give the internet connectivity, then I need to change this gateway manually from the PC side R1 to R2. Then in that situation, this can access the internet via this way. Again, when you come back, this router come online and everything is going to get good. Again, my gateway need to change as a R1. So this is a single PC, so I'm able to do that without any problem. But think about in this way, if my company have the thousands of the PC or 5,000 have the PC or even 100 of the PC or 500 of the PC, Is it really feasible we can do that when we have a problem? No, you cannot go in every PC and change the gateway. It's absolutely not possible to going any kind of the user machine and changing the PC IP. So to mitigate this problem, we use the FHRP, that is known as the first hop, means the very first hop of the PC gateway level, whatever the gateway they have, that level we have to give the redundancy. So there are the multiple technique we have to use. And what are those technique? The technique is going to be used as a HSRP, that is known as the uh, just VRRP, HSRP, and GLBP. HSRP, I just skip the full form.
Hot
Hold on.
standby redundancy
Yeah,
protocol.
yes, how to standby redundancy protocol. That's correct. Sometime I missed that. So, how to standby redundancy protocol, and similarly, this is the going to be your HSRP is going to be your Cisco proprietary, and VRRP is going to be your open standard. What is the Cisco proprietary? What is the open standard? Cisco proprietary is means it is going to run on the Cisco router. Hot standby redundancy protocol, and this is known as the virtual router redundancy protocol. So this can be used, means if you want to use HSRP. So if you have a network like a router, both router are going to belong to the Cisco, then you can use that. But if you are have the different vendor router, let's suppose you want to run one router is a Cisco, another is a Juniper. So you cannot run this protocol because Juniper is never going to support the your any kind of redundancy for the HSRP related configuration because Cisco proprietary. HSRP is just Cisco proprietary. So if you want to use the different router, so you have to use the open standard protocol, that is the VRRP. We will do the configuration later in this section. If I go here in below section, we have the detailed understanding. Let me show you. So we'll do the configuration. See here. Configure the redundancy protocol such as the HSRP. So when we do the infrastructure section now, we'll do the configuration. But I'm not going to do the configuration right now. I'm going to explain the theoretical part so you guys can understand. So this is how. So if I have the same Cisco router, I can use the HSRP. So let's understand how the HSRP, and the third one is going to be GLBP. So one is the HSRP, VRRP. This is for the Cisco only. This is for the Cisco only. This can be any devices, means open standard. GLBP is basically gateway load balancing protocol. Gateway load balancing protocol. So if you have the like provisions, you want to make the multiple router in a same group, just do the load balancing. So there is the GLBP, means you can group the multiple router together and you can just still achieve the load balancing. And they have the different kind of the techniques, but still they all are going to give the gateway level of the redundancy. How they are going to do that? So again, I will draw the same scenario. I have the router R1. I have the router R2. They are going to connect with the switch. This is my switch. This switch is going to connect here. And behind the switch, I have one of the PC. Again, I have the ISP. This ISP is connected like this one. Might be we running any kind of the protocol. We can run here as a static most of the case or the BGP. Only two protocol we run in the WAN. We run as the static or we can run as the BGP. Now, when we come for the IP assignment, so again, my this interface having the IP address 10.10.10.2. This is going to be same. This interface IP, sorry, 10.10.10.3/24. This PC having IP 10.10.10.4/24. But now the gateway. What is the gateway? So in that case, gateway would be my virtual IP address. not any physical IP address. So they use the technique where any FHRP protocol you're going to use, either HSRP, either VRRP, or either GLBP. They all are going to use the virtual IP, and those virtual IP are always going to be announced whether they are active or not in the LAN infrastructure. So in case I can go and configure the virtual IP as a 10.10.10.1. So this virtual IP is going to be primarily associated with the either one router or two router. You just have to define the priority. So there is a priority provisions you have to configure when you're going to define the HSRP, VRRP, or GLBP. So based on the priority, the higher priority in case of the R1 have the higher priority. So it is going to be active on this router. So my gateway of this particular device is going to be 10.10.10.1. And in case my this router is getting down for some reason, if this router is going down, so my gateway is automatically going to be changed to the R2, and then your traffic will keep going to the ISP. So let me do one of the labs so you guys can understand at least how it is going to happen. So at least we can have the hands-on knowledge. So let me do that. I believe I have the lab topology. So I will try to do some lab just for the demonstration so you guys a little bit get more idea about it. I really want to do the later stage, but let me do that. Yeah. Okay. So what we can do that, I'll turn on these devices. These are the PC. So in this topology, we have to reach 8.8.8. This is my internet destinations. And let's suppose this PC is there. This PC is also there. So what I can do that, in this, I will create one of the VLANs that is a 192. 192. This can be assigned on these ports, these ports, these ports. They are all going to be same part of VLAN, and I will assign the IP address 192.168.10.2, 192.168.10.3, and the virtual IP is going to be 192.168.10.1. And for these clients, IP is this, but gateway I'll put the virtual IP. Means this PC gateway is going to be virtual IP. This PC also gateway is going to be virtual IP address. So we'll see how these are going to be communicate to the internet over the WAN. So let me do the configuration and then we can proceed with the further concept. So internet router have some configuration. I will explain what is this configuration. So we can leave it. It is going to save some time, but below devices, I can change the configuration. So I will first change the host name as switch 1. Okay. I'll go here and this is going to be switch 2. Let me change the host name. Host name is going to be switch 2. And I'll go for this router also, or this switch also, and I will just make as a host name switch. This is also switch 2. Okay, let me make a switch 3. In top, it looks a switch 2 only. Give me 1 second. Let me change the name here. I just switch 3. It's not going to be created confusion. Okay, now it's a switch 3. All right. Now I have the PCs also. PC, I need to assign some IP addressing. I will do that. How it is going to assign the IP addressing. This also I will go here and configure the IP. So very first thing, I'll go in the switch. Okay, switch. I'll create the VLAN 192. So because you can create any VLAN, and I need to put. Let me explain. I'll create one of the VLAN here, and I'll put these ports under the same VLAN. Or if you have the multiple VLAN, you can make as a trunk port also. TP you can make if you want to make the multiple VLAN pass through these links. But I have one single VLAN in my topology, so I can make as a access port. Just carry the single VLAN. But let's suppose in router you have two interfaces in different subnet and you want to pass on these links. So access port is not going to help you. You require the trunk port. So trunk port we need to configure. So we'll see in switching how trunk port is going to configure. But in this lab, I'm going to configure the access port and I'll create the VLAN 192 for this subnet. Okay. So let me go that and create that. So I'll go here and create the VLAN 192. You can put the name as a LAN subnet. That's all, and do right. Okay, let me do one more thing. Once I create the VLAN, I need to pass on three interface 0 by 0, 1, and 3. These three interface need to pass this VLAN. So I can go here and create interface. Sorry. I run the command interface range 0 by 0 and 0 by 1. So ETH 0 by 0 to 1, comma, ETH 0 by 3. So all three interface I'm going to configure as a one-time switch port mode access, switch port access, VLAN 192, no shut, and do right. That's all. So if you see on the particular switch, show VLAN brief, you are going to get 192 VLAN have these three interfaces. Ethernet 0 by 0, 0 by 1, 0 by 3. That all are part of these three interfaces. Now I'll do the same configuration over the my switch 2. So I'll go in the switch 2, VLAN 192, name, I can put the LAN subnet. You can put any name, but it's okay. And I will configure the interface range. Interface range command is help to do the configuration one go for the all interfaces. So 0 by 0, 1, and 3. So I will configure ETH 0 by 0 to 1, comma, ETH 0 by 3. Sorry. Switch port mode access. Switch port access, VLAN 192, no shut, do right. And if you do go here, show VLAN brief, you're going to find this 192 also configured. Okay. Now I'll go on the my third switch. Third switch you go and you can configure 4 port now. 0, 1, 2, and 3. All 4 need to be configured in the 192 VLAN. So I'll go here and create first VLAN 192. Name I can subnet, I configure as a LAN subnet. And then after I will configure interface range. This range is going to be 0 by 1 to 0 by 3. ETH 0 by 0 to 3. And switch port mode access. Switch port access. VLAN 192. No shut. Do right. That's simple. And I will exit from there and I'll run command show VLAN brief, and you can see we have this all configurations. So right now we configure these all interfaces and all VLANs. Next step, I will go my VPCs and configure the IP address. So VPC IP address IP 192.168.10/24. And what is the gateway I'm going to use? Gateway, I'm going to use the virtual IP address, but virtual IP address is not configured anywhere right now. So let me configure gateway as a virtual IP address. Sorry. And we'll see how it is behaving. And I will save config. So my config has been saved. Now I'll configure the similar kind of the configuration on the another switch. IP 192.168.11/24 gateway is 10.1 for this PC, you can see. And I will go here and I will simply save config. Done. If you try to ping gateway, it is not going to ping right now. No, nothing is pingable. If you try to ping PC to PC, it should be able to reach. Means one PC to another PC should be able to reach. Why they are able to reach? Because they are in the same VLAN. So they are able to talk. These two port are the 192 VLAN. So that's why they are able to talk. But they are not able to talk to the virtual IP because these interfaces are not configured on the router level as well. So we have to make configuration for the LAN interfaces first. Means these two interfaces must be configured. So let me go on the CE2 router, CE1 basically first, and I'll do the configuration first. So I will go here, enable config tail, hostname CE01, do show IP interface brief, and interface, that interface is Ethernet 1. Ethernet 0x1, IP address I192.168.10.2/24. So I will configure and no shit. That is the very first thing. I'll go in the CE02 as well. And on CE02, I will do the similar configuration. Hostname CE02 to show IP interface brief. Interface is going to be my Ethernet 0x2 IP address 192.168.10.3 to 55 to 55 to 55.0. No shit. So you can see right now I configured these two interfaces. So technically these two interfaces should be able to talk to right now. Because how they are going to talk? If I try to ping from this to this, it's able to reach. If this PC to this interface able to reach, this interface able to reach, this interface able to reach, this interface able to reach. Why? They all are the same subnet, same VLAN. So let me test to just make sure we have the connectivity. So if I try to ping dot 2 should be reachable. Yeah, it's reachable. Dot 3, it's also reachable. Yeah, it's reachable. If I'm going 𝗵𝗶𝗃 true also, it's reachable. Dot 3 also reachable. But if I try to ping dot 1, it should not able to reach because there is no any virtual IP configure explicitly in the any router configurations. So it cannot be reached. And even I go for the R1 and try to ping the R2 IP address. 192.168.10.3 should be reachable. Let's wait. Yeah, it's reachable. So we have the LAN connectivity entirely, but how we can make the gateway level redundancy in this configuration? How it is possible? What configuration I need to do that? So for that, I required HSRP configuration or VRRP configuration or GLBP configurations. Either of them I need to configure. Then only I can achieve this requirement. So let's do first the HSRP configuration. Step by step HSRP configurations. So first of all, when you go for the HSRP configuration, you always go on the interface. HSRP never going to configure in the global command. It is means you cannot configure HSRP on the global mode. It is going to always configure on the interface mode. Means you have to go on the interface and then you have to enable the HSRP or VRRP or GLBP. Whatever you want to enable, that should be interface level configuration only. Clear? So I will go on the interface, this one, and then there is a command standby. Okay. If you are running the HSRP, that is a standby. If you're running the VRRP, so there is a command. VRRP is going to be VRRP, and then you have to give the number. So you just have to run the VRRP and then just give the number. So we are running the HSRP. So the command is going to standby, and then you have to get a lot of options. You have the authentication, you have the group number, you have the BFD, you have the IP, IPv6, MAC address, reference, preemptions, priority. So what you have to understand in this all configuration, most of the case you should, or always you have to configure this. Most of the case authentication, you have to configure the IP, you have to configure the preemptions, priority, and track. These all things are very important. Means this number is represent your group number. Authentication, you want to authenticate, means both neighbors should be authenticated with some parameter, some password. Then only they are going to be authorized to make the HSRP neighbor. If the authentication is not going to be happen, your HSRP is never going to build. Similarly, you have to configure the IP, means you have to define the gateway, virtual IP address. So if you have to define the virtual IP address, that's always going to be in a standby IP. And then you have to give the virtual IP address like 192.168.1.1. And similarly, preemptions is lower the priority active router. Means we'll understand what is the preemption. I will explain. Priority is the priority level. Means by default, both router having the 100 priority. So if you want to make any router as active or primary, you have to increase the priority more than 100, like 150, 101, anything you can do that. So it will increase your priority. And based on that priority increase, you can just talk to each other. So this is how it is going to happen. So let me configure first of all the group number. Make sure whatever the group number you're configuring here, the same group number is going to be there as well. So I'll configure the group number. Let's suppose 192 because we are using the 192 VLAN. And then standby, and you just have to give the IP. What is the IP? So IP is going to be 192.168.10.1. There's a virtual IP. Means whatever the virtual IP you configuring, that going to define as a virtual IP. So standby group number IP is this one. Okay. Standby 192 again. And if you want to set the priority, this router want to become my primary. By default is 100. So if I want to make as a first router of this one, so you can see this is change as a group 1 and 2 become the active. Why? Because there is no other router available in the group. So how this is going to become the primary? So that's why it's become the by default active. So priority I'm going to give is a by default is going to be 100 priority. So I'll give the 150 priority. That's two things I configured. Leave it right now. So let me show the current configuration. Show run. Interface ATS0x1. So you have these two line configurations. Now I'm going the C2 router and I'm the already interface. So a standby group is this one and IP is going to be, I'll give that 192.168.10.1. That's all. I'm not going to do any other configuration. By default, the priority is going to be 100. So just wait for a while. Wait for a while. Wait for a while. Let's see what is happening. Let me show standby brief. So see, already it's become active. So I was waiting for the syslog message, but here it's come, but active one not coming. Why? Because already it's give the syslog message here. It's an active router. So it's not going to regenerate the active message. But in the C2, you can see this generated the active, the syslog message. This has become my standby. You can see this is showing that this is going to become my standby. So if you run here, so standby. So standby brief. So you see, this is my standby router. And most important, you can see here, the parameter you are going getting here, the group number is 192, priority is going to be 100, standby is this router, active router is this one. And what is my virtual IP? This is my virtual IP. So by doing the single line configuration, this single line configuration, we enable the HSRP. Even this one, it's enabled the HSRP. You can see this is the priority 150. This is the active router. This is the local, and this is the standby router. Now, if you go for the virtual PC, means you go to PC and try to ping .1 IP address. So it's able to reply. Which router is replying? It's replying by R1, C1 or C2. Which one is replying right now? Any guess?
C1.
C2.
One, sir.
C1 is replying because
Yeah,
C1
because
having
high
the
priority.
higher priority. Because here C1 is the higher priority. That's why it's replying. Make sense? So that's why it's replying. Now we have to understand few more things. One thing I explain, if I am going to configure the priority, okay? Then if let's suppose my priority is going to be same, then which one is going to become my active? Any guess? If let's suppose I leave the priority 100 also here by default, then which one is going to become my active?
Lowest MAC address based and port number based.
Okay, let me do that. And let's see that what is going to be happen. If I go here and I'll remove the priority. Let's see what is going to be happen. I'm waiting for syslog message. Technically, if priority is going to be tie break, okay, the router which having the higher IP address, interface IP address, that will become my active. So let's wait. Actually, there is no preemption configured. So let me configure the preemptions. Then it will standby 192 preempts. Let me do here also. I'll explain what is a preemption here. Okay, now let's wait for a while. Show standby brief. So higher IP address is this one, right? So run interface 88.0/2. So you can see the higher IP address is 192.168.10.3. And this is my lower IP address. So run interface 80H. Is 0/1. Show run interface 88 0/1. Should take role. Let me bounce the interface one time. Let me do that. Interface Ethernet 0/1 shut. No, shut. Okay, let's wait for a while. Now let's see who is going to become. So this is going to become active. And let's see whether it's going to be active or it's going to become the standby, because we also configure the preemptions. See, so now it's working correctly. This has become my active and this has become my standby. Why? If you go and check if in HSRP, if both router have same priority, then who will then how active and a standby selection will happen. Just if you search that, then you're going to get some articles. So the active standby selection is the if the both HSRP have the same default priority, then the highest configure the IP address in our interface. So which one is the highest? Highest is basically
C2.
C2. C1 is this 192.168.10.2, and this is going to be my .3. So this has become my highest IP address, and that's why it's become my active. Make sense? And even this is going to be down. Let me make the down. If I go here and make the down this interface now, it is 0, it is 2, and I'll shut down. If I'm making the shutdown, so this has become my active. Okay. Show standby brief. This has become my active. But the moment I will no shut this router, it will take this role. Why? Because we enable the preemptions. So what is the role of the preemption? Preemption is, let's suppose I am the active router and I am the passive router for some reason. Okay. So this is the active router and this is the passive router. Let's suppose we are running the HSRP here or VRRP. If I am the active, so that definitely my either priority is higher or my IP address is higher. This priority is lower or IP address is lower. But what if I'm going to be down for some reason, this router is going to be down, this will become my active. If there is no preemption, if this router will come up, technically this router having the higher priority. So should become active, but it will not become active. It will never going to become active. Why? Because there is no preemptions. So if you configure the preemption, this command you're going to do that. So if it is going to become online, it will take his role and become the active router again. So preemption is going to give the power to take role your back once you come online. If there is no preemption, so automatic it will not take role unless or until you're going to forcefully shift the traffic to the primary router. That's why the preemption you must have to configure. So if you go and you just search it even here, so see preemption by default HSRP preemption is disabled and you need to enable manually. Then with the higher priority or higher router IP will take this role and make the communication. So if you even search that, what is the role of preemption in HSRP, you're going to find some kind of the similar concept what I explained. So preemption is allow higher priority router automatically take back the active role from the lower priority router. When router, superior router recover or rejoin the network, means in case of the any failure is going to be happen, and after failure it is going to rejoin the network, it is going to give the flexibility to take the role back so that it is going to be again start serving the network. Make sense? Meaning of the preemptions, guys. Everyone understand what is the role of preemptions?
Yes, sir.
So right now you can see this router is active and this one is down right now. This is down. So if I'll do the no shut, technically this should become my active. What do you guys think? Yes, no, or maybe? It should become my active. So let me make the no shut. And let's see what is going to happen. You can see syslog is coming. Your interface has come up. And it should go and declare I am the primary router. So first it's going in the standby. Okay. Speak to standby. And let's wait for a while. Show standby brief. Why it's not taking the role? Very weird. Okay, I don't know why it's not taking on the role. It should take. Let me increase the priority. Standby 192 priority. Let me make 300 for this router. Sorry, 300 we cannot make. The maximum is 250. So let me make 255 is maximum. So let me make 240. Let's see. Now it's becoming active. So even with the higher IP address, it's not changing the role. Should check. Okay. So one is problem now. Sorry. What is the problem? Let me show you. See why it's not happening. It's my bad show run interface. See, actually, I missed one thing. Okay, the priority we remove, no? Okay, the priority we remove. Okay, so I was saying the priority is still there. So definitely it should take with the higher priority in HSRP with same default priority, which router will become active. Definitely the higher IP, but it's not happening. So I will check this one with a different iOS. Might be this old iOS having some bug. Okay, so it's not getting the switch over because it's a very old iOS which I'm using in this particular lab. But you can see if I have the higher priority, preemption is enabled, it's taking. But in case of my priority is going to be same. The simple calculation tiebreaker is going to be highest IP address, as we know that. So that's why it should be the highest IP. If default priority is same, then highest is going to be take a role. But in case of the same priority, means if you have the manual priority configurations, definitely the higher is going to take a role. So let me make the primary router this one. Let me make the 250 priority here. So it will become my active again. Standby 192 priority. I'll make 250. Now you'll see show standby brief. It's going to be my active state. Now you can see this is my active state and this is my standby state because it's already exchanged the message. So there are a lot of messages also. If you talk about the HSRP, they have the messages like they go with the different stage. They go for the learn stage, then you go for the listen stage, then they go for the speak stage, and then they select the either active or standby. So whenever you go for the any kind of HSRP, let me show you in the packet capture so you can understand that also how the stage is going to be happen. So if I'm going to be, let me try to show you in the packet capture. So which interface it is? 0 by 1. So I will go here and try to show you. Let's wait. I want to show in the wireshark how the packet are going to be exchanged if I'm going to shut down any kind of the links. So you will see that. Okay. So you can see there is a active standby. This keep sending them messages on the multicast address. What is the multicast address? That is a 224. So whenever you're going to configure the HSRP, they use the multicast address 224.0.0.2. And they are just sending the messages standby, active, standby. They keep sending the messages. But when you go for the, let me shut down this link. If I shut down this link, see, no messages coming right now. Passive. You can see advertise passive, and this become my standby. Let me show you. This will become my active, and this show standby brief. This is claiming himself as active, but no other messages we are getting reply from active state, active etc. But no reply I am getting from any other router. Why? Because we lose the connectivity. But the moment I will restore this link, you will see how the messages are going to be exchanged. Now you see, it's going the speak stage. You can see they are getting the gracious ARP reply, and they are going to be speak active state. You're not able to see the learn state right now, but they are going to be see speak active standby, and you will see probably here show a standby brief. It's active. Now you'll see one of the message gracious ARP. What is that? You just focus on this message. Anyone know what is a gracious ARP message in the HSRP? What is the role of the gracious ARP? Any idea?
It helps to check whether the IP address is assigned or not. Like it could be helps to avoid the duplication of IP address.
Okay. Any other idea? What is the gracious ARP in the HSRP, VRRP or GLVP? You can see we have the one of the packet that is a gracious ARP here. So gracious ARP is a feature the moment you configure the virtual IP. You see here, it's going to broadcast in LAN network. Hey, if somebody want to reach on this particular MAC, come to me. So it's proactively going to announce himself, the router who is active router. It's going to tell to the entire LAN network, hey, if somebody looking for this IP or this MAC, come to me. That is the role of the gracious ARP. So if you just search your ARP versus gracious ARP, so you are going to be get some same. So standard ARP resolution map dynamic IP address to static physical MAC address of the network, allowing device to find each other. Gracious ARP is unsolicited broadcast ARP packet sent by the device announce its IP address. That's why you can see the broadcast packet FFFFFF. It's sending the broadcast to the LAN network. So it's just sending the broadcast message to all the LAN network. Hey, if you have any kind of the requirement of this IP address, come to me. That's also a help to detect any IP conflict or update the ARP table if any network want to assign the same IP address. So gracious ARP basically GARP is announce I have this IP address and this MAC address. If anyone want to come, just come to me by using this particular message. That's why you're seeing the GARP message here. Make sense? Everyone, GARP clear? If somebody, and same is going to use for the your HSRP and VRRP and GLVP. GRP is going to be everywhere. If you are going to learn the Palo Alto firewalls, you are building the HA. You are going to learn the FortiGate firewall, building the HA. GRP is going to be there. Even you are going for the checkpoint, GRP is going to be there.
So this is like an automatic feature that an automatic feature?
Yes, automatic feature. You don't have to do anything. Whenever you're going to enable the HSRP in the LAN infrastructure, it will automatically going to be configured and it is going to build the, 𝗙𝗔 table in the LAN infrastructure. So any devices looking for the like connectivity to the virtual IP address, they know what is a MAC address, because you can see the MAC address against this IP address is already mapped here. You can see this one is the MAC address also.
So, but can you disable this feature?
No, we cannot disable. If we disable, HSRP is not going to work.
Oh,
If you
so
disable this, if you disable, HSRP is never going to work for you.
okay, but isn't this like doesn't that present some type of a security issue here? So if somebody was like on the LAN without any permission and this device just announces itself like that with all those
That's
information in.
absolutely the design. I understand your problem. Security
Yeah.
is not going to happen. It's only going to happen when you want to build this HSRP or VRRP.
Oh, okay. Thank
Until
you.
if you're not building the HSRP and VRRP, this GRP is never going to be announced. If I disable this VRRP HSRP, the GRP will going to be stopped. Okay. So they will only send the request for the virtual IP address, no other IP address. They will only send the GRP request for the virtual IP address to the LAN. So, hey, you want to come to me? Come to me. And only the device who is the active device that is going to announce the GR. If this is going to down, then who is going to become my active? Amrita, Dinesh, Saifullah,
E2.
CE2. So now this will start announce this GR. So if anyone want to reach, then they will start reaching to this gateway and then it will go to the internet. If GR feature is going to remove here, you're never going to be make any gateway level redundancy and you cannot do any kind of the communication to the internet. That's the beauty of the GR. And I mentioned that there are a lot of messages also. Hey, why my packet capture is not showing? Okay, let me do the packet capture on this particular interface. G2. So I want to show the messages also, but let me. Okay. So hello, active standby. You can see all the messages, but let me go here and try to shut down this interface and no shut this interface and config interface Ethernet 0/2 shutdown, no shutdown. Let me show what is happened. So you can see it's just sending the hello packet, hello start active. So there are the packets. Yeah, see, speak, learn. There is a stage, learn, speak. That all should be there, but it's not showing in the packet capture. There should be learn, listen, speak, and active and standby. So learn, we are not able to see for some reason. Let me try to search learn. No, we're not able to see. Hello, 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 hello. Let me try to see what all information is coming here. So it's not showing that. Okay, let me do one more thing. Let me try to debug HSRP, IP HSRP, debug standby. Packets. Okay. And let me just show you debug events. Okay. Now let me go and do the shut no shut. Shut no shut. And let's see what is happening. See, so here all these stages. So okay. So there are the messages. In HSRP, we have the lot of messages. You can see here. So if I configure this HSRP, so they have the listen message. Okay. They have the learn listen. So learn packet also should be somewhere. Okay. So there are 4 type of the messages are going to be exchanged. Learn, listen. Listen we see here. And then it is going to be speak. You can see the speak message also there. You can see they are talking to speak. And then they are going to convert as an active standby. But there should be learn as well. Learn. You guys able to see learn somewhere? So learn is not available here. Learn is going to be there. Might be you're not able to see that, but you can see here HSRP message type. HSRP message type. So if you go for the HSRP message type, you're going to find that. See here the you can see initial, learn, listen, and speak in a standby. So this all is going to be messages. So whenever going to configure, if we're going to create the packet capture or debug, so we'll see listen, speak, and standby inactive. But initial and learn probably I'm not able to see, and I need to do again packet capture. But these are the message you should know about it. These are the messages in the HSRP you should know about it. This is how you can configure. So now we understand about the preemptions. We understand about the priority. We understand about the gracious up. Is it clear, everyone? Or whatever we have done? Any doubt till now here? I hope I'm going in a very detail and it's helpful for everyone. Please let me know if any doubt till here, because we have to move to the next step now. Because we configured the HSRP and we see HSRP is working perfectly fine with the preemption and everything. No doubts, shall I consider? Can someone?
Sir, there was like you were showing track as well. So what is used for that one?
What one?
Track. Earlier when you showed
Yeah,
that.
track. I'm going to show the track. Okay.
Thank you, sir.
Means still here it's clear, right? LAN part is clear,
Yes.
right?
Yes, sir.
Now I'm going in the WAN part. Then I'll explain the track. Okay. So let's configure the WAN part, because I have to do the real-time failover, and then you guys will understand. So in this router, what I'm going to do that, you can see I configure this IP address 100.01.10.10.2 and 100.02.10.10.2. And if you show IP route, we are using the static route pointing toward this router, this one, just one route as a reverse route. So let me configure this WAN interface also, C1 and CE2. So I will go here, interface. What is the interface? ATS 0x0. IP address is going to be 101.10.10.1 to 55. What is the, let me see. What is the net mask I have taken here? /24. Another IP, Ethernet 0x1. One 102. No, sorry. On this need to configure another router. Okay, not this one. Config interface ETH. I'm going to configure as a Ethernet 0x1. IP address is going to be 10.10.1 225.2.5 no shift do right. Okay, so let me ping you first. .2 should be reachable. Yeah, it's fine. And if I go here as well and try to ping the peer IP address, .2 should be reachable. Yeah, it's reachable. Now, next step. If I want to reach to this destination, can I reach? Yes, we can reach. So I can do that. I can add the static route. Right now, if you're going to reach, it is not pingable. If you're just trying to ping 8.8.8, it's not going to reachable. Say it's ICMP unreachable. destination is unreachable, but I want to make the reachable. So this internet router have the default route pointing toward this R1. Okay. But this router doesn't have any route to go on the 8.8 destination. So I can put in the C1, one of the default route, IP route 0.0.0.1. And the gateway is going to be my true and do right. Similarly, here I'll go and put one of the default route, pure static route, no BGP. We'll do the BGP later in detail. So it's a very basic routing. And this is going to my dot to and do right. That's also done. Now what next? Now if I try to ping, it should be reachable. See, it's reachable. Even going for the VPC2, it's trying to ping 8.8.8, it's reachable. So what is the traffic flow right now? Anyone tell me? If I'm pinging from this PC to this one, which path is taking after this switch? It's going by this way.
C01.
C01. And why C01?
Because you have configured static route on the internet.
Static route also here also I configure. I also configure static route here.
But from internet to CE1,
Okay.
sir.
Reverse one, right? Okay.
Yeah.
And if I change it's a very good battalion, means if I change the default route, let's suppose on the internet side, I change the default route. Let me do that. Let's have some fun. Okay. Okay. So there's two default route. Okay. So let me remove that default route. Okay. This one and this one also. Okay. Below one, you can leave it. Now we have the default route pointing toward 102. So in that case, will I able to ping or not? What do you guys think? See, in this internet router, I have the default route pointing to this next hop. And this also have default route pointing to this. There is no default route available, but there is a default route here. So if I now ping, will it going to ping or not? Any guess? Any guess? Bad or might be the right? I don't care, but just guess.
CE01 is a primary HSRP, right? Primary
Right.
active router, right?
Right.
So in this case, it's never pinging.
Okay, that's good. Let me try. It's pinging. Dinesh, Saifullah, Fishrat, why it's pinging? Battalion, why it's pinging? See, I changed the default route even toward the secondary router.
Due to HSRP configuration.
HSRP, okay.
Because you made
Actually,
that link, you removed
yeah.
the route, so maybe we are taking like CE02 path.
Any
Considering that
track
as a
objects
count?
you configured, sir, previously?
No, nothing. It's happening due to there is a symmetric routing and there is a asymmetric routing. Do you guys know what is asymmetric routing?
No idea, sir.
Yes, sir. The ongoing traffic and return traffic follow the different path.
Yes. So that is happening because your traffic is going via this path. Sorry. Your traffic is going via this path. Okay. But reply is coming via this path. So this is the path 1 and this is the path 2. So your path is asymmetric. This is known as asymmetric routing. Got it? This kind of routing is going to known as the asymmetric routing. Means earlier, let me show you the trace. If I'm going to take a trace from this PC, 𝗏.𝗏.𝗏. See, the first hop is going to the 192, and this is now the question is Why not showing the virtual IP address in trace? Why it's showing the physical IP address in trace? Any guess? We make the virtual IP address a gateway, right? From the PC point of view. We make, na? What is the gateway? This one. But it's never showing the my virtual IP in the trace. So take a note. In any kind of the HSRP, VRRP, GLVP, Palo Alto firewall, FortiGate firewall, checkpoint firewall, SD-WAN, virtual IP never going to part of the trace. Virtual IP never ever going to part of the trace. Only your physical IP is going to part of the trace. So that's why your traffic is going directly. This is the layer 2 network, flat layer 2 network. So from this PC, it's landing to this PC. Why this PC? Because this is my active router and then reaching to a destination. But when you take the reply, if you go the R8, let me go on the internet. And if I'm tracing the PC IP address 192.168.10.10 with source 8.8.8. See how the trace is going. This one. So it's backing from the R2 router. It's backing from the R2 router. The first stop is 102 and then it's coming back to the your R1. So your forward traffic going via the R1, see, but and then it's reaching to destination 101, but your return traffic is coming from the R2. So this is the asymmetric routing. Clear? So still we have the reachability. In case of the routing, even we have the asymmetric routing, it's going to work. Your traffic is going to talk. But if in case of in between we have any firewalls, your TCP three-way handshake is never going to be complete. Let's suppose instead of router we have the firewalls. Your communication is never going to be through. Because firewall always verify three-way handshake. And if three-way handshake is not going to happen, what is three-way handshake? Sync, syncac, or your acknowledgement. 3 packet is going to be happen. So if three-way handshake process, you going to be send the first message is synchronization, synac, synchronization plus acknowledgement is going to reply and then acknowledgement. And that should all happen via the same path. If it is not going to happen with the same path, they are never going to be communicate. So in routing, it is going to work, but in firewall, it's not going to work. So let me correct this one. So I need to do corrections. So I will add one more static. This is the floating static route. Why floating static route? Anyone know what is a floating static route? Anyone know floating static
the
route?
primary one went down, automatically the backup collection will take and forward the traffic. That is the concept.
Floating static route means you have the two static route. One is the default AD. What is the AD value of the static route? AD value of the static route. What is the AD value of the static route?
Static 10.
No, 1.
Oh, sorry.
One.
Forgot it.
1 by default. If I'm going to configure this static route, this will take a precedent over this one. This is the 10 explicit I have given. So now in my routing table, we have the two static route, floating static route. Means one is this one, primary, and this is secondary. So now you can check in the routing table which route is going to be installed in routing table out of these two. First one or second one?
First one.
Because having the lower AD value. You can
Lower
see
AD value.
this has been installed. Now if I go again and check that, my trace is going via this path, and if I trace from there also, they are also going by the same path. So now the path is going to be my symmetric. You will see the same path my traffic is going to start from the source to destination and destination to source as well. So let's discuss about the track OMP. See, so your traffic is coming from 101 and you're also going from the 101. So your path has become symmetric now. Now moving the next step. In case my router is getting failure, my traffic is safety. We know that. Let me show you. In case my router is going to be down, send by brave. This is my secondary router. But in case my router is going to down, your failover is happening. Shut down this router. You can see this will become my active router very soon. See, this become my active. And my traffic start going via the primary traffic. Everything. Again, it will come online. It will become active. So we just have to wait for a few seconds. So my router level failover is happening. It's clear. My purpose has been solved. If router is getting failed, my failover is going to happen. But what if my link is going to fail? If my router is up and working, but my link is going to fail, WAN link is going to fail, my gateway is going to fail. So we'll discuss the IP SLA in very detail. So IP SLA tracking, I will explain in the upcoming sections. In the same HSRP, we'll cover again, and I'll cover this IP SLA in network assurance. See, we have the IP SLA configurations. So I'll cover how the IP SLA based tracking also we can do that. In the HSRP, same lab I will do that. But we have to wait for a while. But for time being, let's track the WAN interface. If my WAN interface is going to be down for some reason, then how I can do the configurations. So let me first make the normal conditions. So if I go here, show standby brief, you can see this is my active router again. And this might become a standby router after the failover recovery. It's a normal process. It's not a big issue. But now let me start doing the WAN tracking part. So how we can do that? So you go here and interface ETH0x1. Standby, what is the group? 192. Track. What I want to track? You can give any kind of a track, let's suppose 10. And you want to decrement. What decrement? You want to decrement the value. Let's suppose, actually what I want to do that, let me first explain. In our topology, we have the R1 and this one is the R2. This one have the priority 250 and this one having a priority 240. Okay. This is the WAN value. This is my WAN. I connected the link. So I want to track this link and my router is up, but link is getting down for some reason. So definitely if the traffic coming from the LAN, it will going to black hole here. It will never going to the WAN internet link because the traffic will come from the LAN side. PC is going to send the traffic to the switch. Switch is going to send here and it is going to drop because there is no further gateway available to go on the internet because WAN link is down. So I want to track this link. And if this link is going down, I want to decrement the priority byte with a 50. So 250 minus 50. How much? 200. So the priority is going to be lower. This is going to become higher. So your traffic is start going via this link. Got everyone concept? Saifullah, Saik, Parth, Ravi, Dinesh, Badalian, Amrita. You got what I am trying to do that?
Yes, sir.
Yes.
So basically I decrement the value in case of my track is going down. So track and decrement, let's suppose 50. Okay. So, but how the track is going to work? So show run interface ATS0x1. So you configure the track 10 and decrement 50, but there is no track. Show track, no track is configured. So let me configure the track, give the number track 10, and now I'll configure the interface. What interface I want to track? I want to track the interface ETH0x0. Okay. That's all. And what I want to track? I want to track the line protocol. If line protocol is going to down, it's going to make my link So this is my track configuration. You have the lot of things also, carrier delay and all, we don't require. So if you run the command show track, you're going to see here. Now your track is showing. Track is the method to track any kind of the interface, any kind of the like. Give me 1 second, guys. Just let me adjust my chair. 1 second. So track is going to give the idea whether your link is up, down, whether it's having any problem or not. So here I'm going to configure the track 10, and track 10 is monitoring my line protocol, and line protocol is showing up. And since what time, you can say 00 seconds. And this track is configured under the HSRP 192 group. You guys able to see that? Everything's about a track. We configure track 10 and we are monitoring the line protocol of the interface. Times and where it's been called, it's called in the HSRP. And what is the line protocol? If you go here, show IP interface brief. See, this is my line protocol is up and up. In case my line protocol is going to down, then what is going to be happen? My track is going to be down. And if my track is going to be down, then what is going to be happen, guys? If my track is going to be down, then what is going to be happen?
It will switch the traffic to another
priority is going to be increased by 50. So how much it is going to be happen? 200. And what is the priority for this one?
240.
240. So this will become my primary. So let me shut down this link. I'll go and shut down this link. So I shut down this link and you see here show IP interface brief. Your protocol must be go down. No, protocol is not getting down. Actually, this is a virtual Ethernet. So protocol is not going to down. So still it's understanding the line protocol is up. Okay, so let me try some other method. Okay, so it's not getting down. Let me do one thing. Let me go in the internet router. I'll start this interface. Let me go there. Show IP interface brief. Interface Ethernet 0 It's a virtual interface, not so very hard to simulate. Let me try. Still not getting down. See? So only one option we have. We have to shut down this interface manually from here. Because the virtual interface, it's not making the peer down. If you have the physical cables or LAN cables, the moment you remove the cables, protocol is going to be down. But it's a virtual, so it's not happening. Okay, so let me do one thing. No worry. Let me restore. So let me do manual shutdown the interface from this router. So I'll go here. Show this is my protocol is up and working. So I'll go in the config T and interface ETH 0 and I'll make the shutdown. Now definitely it is going to be down. The moment I'll make the shutdown, see your track has been go down. You can see automatic your track has been go down because it's monitoring the line protocol. And the moment I just make the shutdown, my interface, my track has been go down, and you can see this router become the active. The peer router become my active. Show standby brief and become active. And how much priority for my remote? This local priority is 240. But what is the priority for this one? Show standby brief. This priority is only your 200. Why 200, guys? Why 200?
By 50.
Yes, the decrement by the 50. You track the interface and you can see this is protocol is down. Why? Admin make shutdown. Even showing the reason why it's become a shutdown. Because admin, you make a shutdown. That's why it's a shutdown stage. So this is how it is going to happen. And if you run the command, show run interface, ETH 0 you have this configuration, but decrement. Again, I'll restore the interface. Then what should be happen? If I restore the interface, then what is going to be happen?
automatically it increment 50, right?
R1 is going to be increment 50, na? Not R2. Amrita?
Yes, sir.
R1 is going to be increment by 50.
Increment 50, yes.
Yes. So I'll go here and Ethernet 0/0 and no shunt. And you'll see this will become again active. So see, your line protocol up, your track is also going to be up. See, your track is up because your line protocol is up to down to up, and now you become the active. Show standby brief. So we understand the track as well. So in case of my interface is going to down, you can do the quick recovery by doing the track features. Make sense, everyone? Is it clear? Give me thumbs up if it is clear
Yes,
to
sir.
everyone.
Yes, clear.
All right, very good. So we left with the one concept with HSRP, the next hop tracking with the help of the IP SLA. So I will cover this in the IP SLA sections. So let's suppose this link is up. Think about this link is up. But you have an issue in the internet cloud, ISP. Your IP is unreachable for particular that path. How you're going to track those IP? So for that, you have to configure the IP SLA. Okay, so IP SLA is the feature where we have to track those IP address, and based on that IP SLA configurations, you can do the config. Let me cover that also. We might be skip later on. So you go here and let me cover this topic, IP SLA, services, IP services. We are talking about the HSRP right now. Not where it's IP SLA. IP services. Let me go here. IP services. Let me try to find IP SLA architecture network assurance. Okay. Yeah, here. So what is the IP SLA? Let's understand this IP SLA concept as well. What is the IP SLA and how it is going to work? So IP SLA is a feature. If you're going to configure the IP SLA, this is just going to be monitor any destinations based on the loss, latency, and jitter. And based on that monitoring, you can just take some actions. So you can see simple, you just have to configure some reachability, means it will send the message to the particular destinations. Then say you are up or working, you are down or up. And based on that, if any kind of the issue is going to happen, that particular interface or IPs, that is going to be report back to you based on that particular IP SLA configuration, and that is going to be take some actions. Means let's suppose in our case, what I'm going to do that, let's suppose take an example. I'm not going to configure this interface monitoring, but I want to make sure if my 8.8.8 is up and working, then my traffic should go via this link. If it is going to be down, my traffic should fail over to this link. This is my WAN IP address somewhere configured. Then how I can track this 8.8.8? That is the one thing. Another thing, I want to track this IP. Let's suppose my interface is up and working, but this IP is not available. This IP is not reachable from my network, from this router. Still my failover should be happen. So it can be only happen with the IP SLA. So what is the IP SLA, guys? So if I talk about the what is IP SLA in Cisco? So you're going to find some definition. Cisco IP SLA is Internet Protocol Service Level Agreement. And why basically use? This is a Cisco iOS feature actively monitor network performance in real time by generating a synthetic traffic. Means it will try to ping. And quick, let's suppose I'm keep saying, hey Dinesh, and you say, yes sir, I'm available. Hey Dinesh, yes sir, I'm available. So after 3 seconds or 5 seconds, I keep saying, hey Dinesh, hey 𝗿𝗏𝗧, hey Amrita, you available? Yes, I'm available. The moment I'm not going to receive any kind of response from you guys for a certain period of time, I will understand you guys are not available. And I'll declare my meeting has been dead or meeting is not working. Similarly, IP SLA is a feature that is going to be send the synthetic traffic in KIP after some time. In KIP interval, just monitor your latency, loss, and jitter of your network. So it is going to use for the active monitoring for your ICMP packet, UDP jitter, or HTTP packet. And based on that, you can design automatic failover. Or if you have the wide video quality monitoring, you can do that also. Services verification also, you can do that. So for here, we are going to configure the IP SLA for the monitoring. And this is what we have to learn in this section. So you understand the meaning of the IP SLA? You want to configure the IP SLA, guys? You know why you use the IP SLA? Any doubt? Clear IP SLA meaning?
Yes, sir.
Okay. So now we have to configure the IP SLA. How we can configure the IP SLA? So simple. We have to define the IP SLA. Okay. So I'll go in the C1 and I can configure the IP SLA and I can give any number from this. Okay. So I will give the number. Now the second step after going there, we have to send the ICMP echo message. There are a lot of things. You can see if I go here in this section, you can say DSB message, you can send the DNS message, you can send the ICMP, you can send the HTTP trap also you want to send to that. You can send that also, but I want to send the ICMP echo operations. So I will send the ICMP echo and which destination I want to send that. Which destination? I have the multiple options. If my internet link is quite big destination, I have the multiple ISP. I want to track any ISP, Google DNS. Let's suppose this is my internet link. I want to monitor my Google DNS should be always reachable. 8.8.8, 4.2.2.2, 1.1.1. So I can keep the destination like 1.1.1. So right now I am going to trace 8.8 because right now 8.8 is reachable from my router. So I can put the destination as the 8.8.8. Now you can define the source interface from which source you want to initiate the traffic while doing the ping that particular interface. So I can use the source. You can go here, clear the source IP or source interface. Source interface, I will use that is a Ethernet 0x0. And now you have the option what frequency you want to send that, right? So frequency, I can just give that any frequency, like let's suppose 300 seconds I want to, or might be let me the 100 seconds. That's going to be, let's make it every 5 seconds, not that much long because there's seconds, so it's going to vary. Okay. And what else? We don't have to configure anything else. And I think we are good. So if I go and configure show IP SLA, right? What was the number? I use that.
10, sir.
10.
10. Okay. Okay. So this is going, let me try to ping 8.8.8. It's reaching and IP SLA, we configure that. Now, if I go here, show run interface and ETH 0x1, this is my configuration. Let me remove the, okay, show run section track. Under track, sorry, we configure the method of the monitoring link is the line protocol. So let me remove this configuration, no track 10. Okay, so I remove the track configuration. If you go here and you check again, okay, so track is configured in the standby. Okay, that's fine. Leave it. But let me configure the track configuration once again. So I'll configure the track 10, or let me configure track 20 this time. And this time I want to monitor IP SLA, not protocol. And what is the SLA number? 10. So what I'm doing that I configure the IP SLA first. Under IP SLA, I monitor my 8.8 interface. Okay. And that I'm going to call in the track. Okay. And just make the reachability. Okay. So it will check the reachability and leave it. So now let me track the show track. Sorry. If I run the command show track 10, sorry, 20 this time configure. Okay, 20. So reachability is down. Why it's down? Ethernet 0/0. It's reachable, right? Show run section IP SLA. Should be reachable, right? We can figure the right thing. Okay. So I need to add few more command. There is one or two more command I need to configure. Let me see where it is. I need to start this IP SLA. IP SLA schedule start now. This command is missing. So I need to start. Okay, so I forgot to start this IP SLA. So IP SLA. Copy paste this one. Okay, you have to give the same. Now you have the so show IP SLA 10. Sorry, this is the final configuration. Section IP SLA. So once you define the IP SLA, you have to make sure you start the IP SLA by running this command. If you're not going to start, it is not going to work. So we created the IP SLA, and under IP SLA, we make sure you just allow this destination IP address, whatever destination IP address, which source you want to monitor. That's fine. Frequency is 5 seconds. And now you have to give the IP SLA schedule 10. 10 is your basically IP SLA number and start forever. हमेशा के लिए you just going to start, and that's why you can see show track 20. Now if I'm going to see that, you see your reachability is up and working. I was also thinking why reachability is not working. So because they are doing the tracking. Now I'm going in the my HSRP. In HSRP, we configuring the track 10, but does it valid track or invalid track right now?
Invalid.
It's invalid because now we use a track 20. So let me use the new track here. I'll remove the track and I will just remove this also. And we'll configure the standby 192 track 10 decrement 50, or let me make the 60 this time. That's all. Show standby brief. You are good with this particular. This is active 250, and this is my show standby brief primary. So right now it is pinging which IP address? It's pinging show run section IP SLA. What IP I'm pinging right now? Amrita? 8.8.8, right? And if it is going to reachable, then only this is going to primary. So what I'm going to do that, I will go in the internet router. If I'll make the shutdown this IP address, then what is going to happen? It's going to be unreachable. Make sense? If I shut down this IP address, then this is going to be unreachable from this router. Let me shut down. Shut down and see the log. Wait for a while. You can also try to ping. See, your reachability automatically down. Why down? because that particular router is not reachable. So your track is down. Show track 20. It's down and show standby brief. But still it's showing the active state. Why it's not having any actions? Okay, still track 10 we configured. My bad. My bad. Should be track 20 now. I don't know why it is there still. Should be track 20. Now let's see. See? So your failover will just start happening again. Show standby brief, and this will become 190. Right now is speak stage, learn, listen, speak, and standby. And this is become my show standby brief. Clear? How track is happening? If I make the again no shut, then what is going to happen? This will again become my active. Wait, see, my track is again up. And now again, show standby brief. You are good with that also. So HSRP, I configure everything and I cover every scenario, guys. Are we good in HSRP? I cover the message, I cover the Gracious app, I cover the how WAN tracking, how the IPSL is going to be there. I hope it is clear 100% to everyone. If any doubt, do let me know, guys. If no doubt, are we good for the next stage?
Yes.
All good,
Okay.
sir.
Shall we do 𝗲RP as well today? Or you guys want to digest this one and want to do the next class? How do you want?
Next class
Next
sounds good.
class, sir.
Next class, okay?
Yeah.
So 𝗲RP is going to be easy because we already did everything for the HSRP. So 𝗲RP is going to be easy, and then we'll discuss the theoretical stuff as well. Plan was today to discuss the more theoretical, but we move in the practical as well. That's a good session. So now in next class we'll discuss about this SD-WAN, SDXS, and other configurations. So right, hope you guys enjoy the today's session and try to do this labs, okay?
Sir, I have one doubt. Please
Yes,
show
yes.
the diagram.
Yes, yes.
In this case, we track 8.8. Means in the single router, we configured in loopback, right?
In this topology, we are configured the loopback interface on the internet router. But in practically, you have the WAN IP tracking or might be the any ISP IP or global DNS tracking. Could be anything.
Okay. Maybe in the real-time scenario, it's in the different ISB, means it's a different internet router, right?
Yes. Any router which is reachable from your C1 router, C2 router, any router IP, any global DNS IP address, any data center IP address, any cloud IP address, just you have the reachability, okay? Then you can
Okay, sir.
with the IP SLA.
Okay, sir. Thank you.
Okay. Any other questions anyone have?
Sir, can we get that PDF book?
PDF, definitely you can get that. So you ask to the support team, okay? They will give you, okay?
Okay, thank
They will
you.
give this book to you. All right. Chalo. Thank you so much, guys. Have a great evening to all and enjoy the World Cup final match today also in evening. Okay.
Okay.
But Arin, from which country you are?
USA.
USA. Okay. That's good. Thank you. So it's a very late evening for you, right?
Yes.
What time it is right now?
It is 10
11 and a half
14
hours difference.
10:14 p.m.
10:30, right?
10:14 p.m.
Okay. That's still manageable. Okay. Not too late.
Yeah.
All right. That's good. Thank you, guys. Thank you so much. And we'll enjoy these sessions in next week. Okay. Bye bye. Take care.
Okay, sir.
Thank
Okay,
you,
bye.
sir. Thank
Thank
you.
you.
Bye.
Bye.